Hi guys, let's continue with our class. Let's solve some problems. I'll start with this one. I'll explain it, and then together we'll work on the other ones. Okay, an object starts at 20 meters per second, and after 5 seconds, it reaches a velocity of 60 meters per second. Find and identify the type of acceleration. First, we have to obtain our data. Our data in this problem is, as you can see, is in another color, like an orange color. Okay, the first one, 20 meters per second. The problem says an object starts at 20 meters per second. So this is the initial velocity. After 5 seconds, it's time. And it reaches a velocity of 60 meters per second, a final velocity. Please remember that you have to pay attention to the units of measure. The units of measure in physics will let you know what magnitude it is. If you have doubts about the magnitude, the unit of measure will tell you about that. Okay, so we have our data. The unknown is the acceleration, is what we are asked to find. The formula, acceleration equals final velocity minus initial velocity over time. We do the substitution, 60 meters per second minus 20 meters per second over 5 seconds. 60 minus 20 gives 40 divided by 5. The result is acceleration equals 8 meters over second squared. Okay, now why the acceleration is the unit of acceleration is meters over second squared? Why is it? Okay, I'll explain it in the with the other problem. Now let me share with you my whiteboard here. Okay, so let's read the third problem. It takes a car 1 minute to go from rest. Please pay attention here to this word. Okay, from rest to 30 meters per second. Find the acceleration. Okay, first we'll work with our columns: data, unknown, formula, substitution, calculations, and result. Data, we have, it takes a car 1 minute. 1 minute, time. The unit of measure is time. For time. Okay, 1 minute to go from rest. I told you to pay attention to this word. The object or the car is resting. So the initial velocity is 0 meters per second. And final velocity, it reaches 30 meters per second. 30 meters per second. Okay, unknown acceleration. Formula. Final velocity minus initial velocity over time. Substitution, A equals 30 meters per second. And now, please notice this. Notice the following. The time is the unit of time is minutes, but the velocity is meters per second. Okay, we have two units of measure for the same magnitude. I mean, we have minutes, and we have in the velocity we have seconds. So as you remember, we cannot use two different units of measure for the same magnitude in a formula. So first we have to convert the time from minutes to seconds. Okay, so time equals 1 minute, and we have to use the fraction, the factor of conversion. Okay, my fraction is 1 minute equals 60 seconds. As you remember, guys, As you remember, in the we have to put the minutes in the denominator because we want that minutes cancel each other, then the numerator with the denominator, okay? And we keep the seconds. So the time is equals 60 seconds. Okay, now we can do the substitution. So the substitution is 30 meters per second final velocity minus 0 meters per second initial velocity over 60 seconds. Calculations, I'll do it here. A equals 30 over 60, 30 meters per second over 60 seconds, sorry. Now, when with the calculator or by hand, you can divide 30 by 60, and it gives 0.5 meters per second over second. Now, guys, as you can see, the middle terms multiply second times second, and we have meters over second squared. This is the reason the time in the acceleration, the time is squared. Okay? Now, let's finish with the fourth problem here. You are running at a speed of 10 kilometers per hour and slow down to 8 kilometers per hour after 0.03 hours. Find acceleration. Okay? So we have our columns, data, unknown, formula, substitution, calculation, results. Okay, 10 kilometers per hour. You are running at that speed. So this is your initial velocity. Initial velocity, 10 kilometers per hour, and slow down to 8. So final velocity, 8 kilometers per hour. Time, 0.03 hours. Okay, acceleration is the unknown. And formula, we know the formula. Okay. Over time. Okay, now please notice this. The final velocity is smaller than the initial velocity, okay? 8 is smaller than 10. What does that mean here in the problem? Okay, yes, Sarah, yes, the velocity is decreasing. So when the velocity is decreasing, you remember, the acceleration is negative. The sign of the acceleration is negative. So the result will be negative. Okay? Well, the substitution, A equals 8 kilometers per hour minus 10 kilometers per hour over 0.03 hours. Okay, we use our calculator or by hand. Okay, and we obtain, I'll round the result to decimals, okay? So I'll round it, Diego. Okay, 66 acceleration, 66.7, okay, kilometers per hour square. Okay, so we have to round the result to tens. So this is we are not using all the decimals, only we round it to tens. Okay, so this is the result, and of course we are missing our negative sign here. Minus 66.7 kilometers over hour squared. Okay, well guys, thank you very much for these minutes. Thank you very much for paying attention. I'll see you in the next class. Thank you.